Hello students, today we are going to learn about the iteration method used in numerical analysis and one of the new iteration method, that is Newton Raphson method. First we shall discuss what iteration method means or iterative method means. Suppose I have an equation of the form f of x equal to 0. Let this be a nonlinear equation or a linear equation which is very difficult to be solved. So what I do is I assume a solution x0 for this particular equation. And then what I do is using the equation f of x equal to 0, I will find out a new value x1 which is a more approximate solution. So using x0 and this equation f of x equal to 0, I compute a new x1 which is a more approximate solution. Then this process is continued, that is using this x1 I find out x2, then using x2 I find out x3, then this process continues. And as we go on, it is very interesting to see that these values will get converged. That is, the differences between the found out values will become very small. So that is the point where I say that this value converges. And that means this value will get fixed to a particular value. So I say that that value or the new xi converges to the solution, or this is the exact, it is the solution for this equation f of x equal to 0. So this is how an iterative method works. Now we shall see generally. So in computational mathematics, an iterative method is a mathematical procedure that uses an initial guess to generate a sequence of improving approximate solutions for a class of problems in which the nth approximation is derived from the previous one. We saw that we initially do a guess, then we find the next solution. When we go on finding solutions from the previous one, then finally we come to the end, or we finally understand that what is the exact solution for this equation. Now, iterative method help us in solving nonlinear equations as well as large systems of linear equations. Now I am going to see one of the method which we use commonly, that is Newton Raphson method. So here we shall understand mathematically how a Newton Raphson method works. Suppose I have an equation of the form f of x equal to 0. Okay. As I said that in iterative method, first we have an initial guess. I guessed x0 as the solution of this equation. If x0 is the solution, then obviously I can write f of x0 equal to 0. Right? Now what I do is, this is an initial guess, and from this x0 we find out the new better solution, that is x1. So I can write that f of x1 equal to 0. So, and what is this x1? What you have to keep in mind is that x1 is something we found out from x0. Let f x1 be x0 plus some value. We don't know what h is. So x0 is, or x1 is x0 plus or minus whatever it be. H can be positive or negative, whatever it be. H is some value which when added to x0 gets x1. Okay. Now our attempt is to find h. So first now I can write, since this x1 which is x0 plus h is the solution, I can write f of x0 plus h equal to 0, right? Because I have already written f of x1 equal to 0. x1 is x0 plus h, then I can write like this. Now you might have studied Taylor series. As per Taylor series, or according to Taylor series, I can write f of x0 plus h in terms of f of x0 as f of x0 plus h f prime x0 plus h square by 2 factorial f double prime x0, and this continues with higher order terms. And normally, if we neglect the higher order terms from h square by 2, these values will be very small. So if we neglect it, I can write this equation as f of x0 plus h or is equal to f of x0 plus h f prime x0 equal to 0. I forgot to write before, this is 0. I have already written f of x0 plus h since it's a solution as equal to 0. So similarly I can write. Now I can find out what h is. What is h? H is equal to minus f of x0 divided by f prime x0. Right? So then now what is x1? I can write now x1 as, I have found out h, right? So x1 is now equal to x0. Instead of h, I can write minus f of x0 divided by f prime x0. Now with this assumed x1, I can find out in the same way x2 as x2 equal to x1 minus f of x1 divided by f prime x1. Okay, so now I am going to generalize the equation for xn as xn equal to, xn plus 1 equal to xn minus f of xn divided by f prime xn. So this is the solution for xn plus 1. You can find out xn plus 1 from xn as xn plus 1 is equal to xn minus f of xn divided by f prime xn. Okay, so this is the how you find out. This is how you find out. Sorry. So this is how you find out the approximate or the solution for the Newton for an equation using the Newton Raphson method. What you do is more better solutions. First we'll find out, assume x0, find out x1 using this equation, x2 using the next equation, like that we go on doing, and finally we see that these values which we find out gets converged, or it converges, we can see, and this then finally xn plus 1 will be assumed as the, or it is found out as the solution of this fx equal to 0. So this is how a Newton Raphson method is mathematically worked out. Now we shall see how, or what is basically the underneath principle which is happening, or what is the basic procedure which is happening when you do this kind of a solution. And for that it is better to understand it graphically. So what I do is I am going to draw a graph for this which represent this solution equation fx equal to 0. So first I draw an x-axis, y-axis, then x-axis, then I'm going to draw a curve. And what you have to understand is, this is the curve which represents the equation fx equal to 0. Obviously this is a non-linear equation, because that is why it is drawn as this kind of a curve. Otherwise it would have been, if it was linear, it would have been a straight line. Okay, so we start with the, now what I do is I do an initial guess x0. Now see, we know this curve touches the x-axis at this point, right? And this is the point which is the solution, but we don't know where it passes, so it is very difficult to find out from the equation where it touches the x-axis. So what I do is I start with an initial guess. So my guessed point is this one. I consider this as x0. Now at the point x0, what is the function? Here, this is the point function. So at the point x0, this is f of x0, right? At that point, I draw a tangent to the curve. Okay, so I drew a tangent and this tangent touched the x-axis at a point here, right? And this is our worked out x1. Now what I do is, using the x1, we find out f of x1. So that is what, so from this this is f of x1. Using the x1, this is the f of x1. You understand that? What you have to keep in mind that this is x-axis and this function is f of x. Okay, so for x0, this is the f of x0. You drew a tangent. This tangent cut the x-axis at x1. Okay, and this x1 at this point x1, we find out f of x1. This is the point f of x1. At the point I again drew a tangent. Okay, at this point I drew a tangent, and this tangent cuts the x-axis again at another point, and this point is our x2. Okay, now what we do, again at the point x2 we find out f of x2. This is the point. Then at the point f of x2, let this be the point f of x2. At this point again you find the draw the tangent. Again it will cut at x3. Like that it goes on. Now we can see that as you move on finding newer values, we can see that this is becoming closer to our exact solution, which is at this particular point. So this is how a Newton Raphson method basically is working. We assume a guessed point, then at the point at the point of the function, then you draw a tangent. This tangent will cut at a point which is more closer to the solution. Again at the point of the function, then you find out the tangent, then the process continues and finally you will come to the exact value or exact solution of this equation. So this is how a Newton Raphson method works. So I hope you understood. So we'll just have a review of what we studied. First we understood what iterative method means. Okay. Then we understood why it is better that we use an iterative method for nonlinear equations and very large linear equations. Then we understood what Newton Raphson method is, how we mathematically find out the solution of this Newton Raphson method. Then we then we understood that what is the basic principle behind this Newton Raphson method, or how graphically we can understand that Newton Raphson method is a way to find out the solution. So I hope you understood, and if you have any comments or queries, please put it in the comment box. Thank you very much.